Hello and welcome to my channels. And this today's talk is about routing, asymmetrical routing in Azure. So, what is asymmetrical routing? Normally, in a network, when a packet transit, it go from one point to another, and for this point to the its destination using the same paths. When the packet return, it should use the same path. In some situation, we want to configure a different path, but it's very unusual. And in Azure, you certainly don't want to do that. But this situation can occur when an operator modifies the default routes that are managed by Azure. Generally, is when people add an NVA or firewall. And believe me, this error is really difficult to spot. And as I say, it's generally the error come when you start to add a firewall, and mostly when you don't really understood what you are doing. So in Azure, more or less, the routing is managed by Azure. Azure routing, so you don't have to do anything. The only thing that you can do by default is to add a peerings, so connecting two VNets. And in some VNet, if one VNet has a gateway, you can tell the peering to use this gateway. So Azure, we had this gateway, and you have nothing to do. Just click on the peering configuration, use the remote gateway, and everything will be configured, and the routing will be configured by default. But there is other way to manage and alter route in Azure VNet. The first one, and this is a very common one, is when BGP is onboarded. BGP is a protocol used in a network to exchange route, to exchange prefix, and to say, okay, this is the prefix I have, and this is where you need to go to these prefixes. So BGP is present in express routes. It could be present in a VPN gateway if you enable BGP in root server, that the main goal is to exchange routes, and also in virtual one. But another way to alter and modify root is to use an user defined route, and you add it on a subnet. And this is where the problem starts, because when you create an UDR and add it to a subnet, you really need to understand what you are doing. You really need to understand two important rules. For each IP that uh, Azure need to make routing decision, Azure will check if in the routing tables where you have your UDR default route, BGP route, you will see which prefix fit the IP and which one is the longest. And when I say the longest is the more specific. So for example, slash 24 will be more specific, more long than a slash 16. So if you have two prefix, 10.0.0.0 slash 24 and 10.0.0 slash 16, Azure will always use the first one because it's the longest prefix. The second rule is that UDR, user defined rule, win over BGP, and BGP win over default route, which means that if an IP belongs to a prefix and this prefix is present in a route tables with UDR, BGP, or default route, it will be always UDR that will win, that will be chosen for the routing decision. And the same, if BGP is present but not UDR, it's BGP that will be used instead of default route. Let's take a look at what we can see in practice. So here you can see that we have a very traditional hub and spoke model. We have here our client VNet or spoke VNets. We have the on-premise network. We have a gateway subnet with a VPN with BGP. And we know the routes that will be defined here. So for the spoke VNets, we have two major rules. One is going to the VNet hub with its IP, it's the peering, it's their default route. And the second one is to go to the on-premise network and is go to the gateway using BGP. On the VNet hub side, there is something else because we have paired all these VNet of the spoke VNets, so we can see that it has all the prefixes for the spoke VNets and go for pairing. Now let's imagine that someone want to add an NVA to inspect the traffic going from on-premise to Azure and from Azure to on-premise. So he had an NVA and he had the different the root tables. Here we will see these root tables. First, you need to add for each subnet in the Spoke VNet, you need to add a UDR route that say that to go to the on-premise network, you need to use the NVA IP, and it's an UDR. And remember the second rules that is very important here is that the UDR will win over BGP. And you see, we have the same prefixes, the same prefix. So the routing decision will be to use the NVA. On the other hand, on the VNet hubs, there is something that look good if you check that, but not. What we have, so the operator decide to use the 10.0.0/8 to go to the NVA and keep, of course, the peerings and with the default configuration. But remember the first rule. The first rule say the longest prefix win. The more specific the prefix is, the more precise it will be chose. So here we have a /8 and a /24. So in any case, when the routing engine need to make a decision, when it have a IP, it will always use the peering, which means that the network packet will never go to the NVA. So, but how we can spot an error like this? And there is a trick. This trick is to use an um, a VMs, and we will see that just before. And this is a setup that I have made, which is very similar to the exam that we saw just before. So I have a VMs here. I put some root tables that are associated with subnet. So the root are very simple. So as you see, so I choose a prefix, the on-premise prefix that go to a virtual appliance with the IP of the virtual appliance. And I associate one of the subnet that I have in the configuration. So if I go to the VMs here, I have two tools that I can use to get the routings. The first one is to use the connection troubleshooting. And here I can select an IP address. I can use IPv4. I can use ICMP. And here you see that I can use port scanner and NSG connectivity. What I will do is I will use um, simply next up. It will tell me which hop it will use. But be careful. So it can take sometimes. It's not very immediate. So you can, with this tool, you can really understood which next up is used. Another way that is more quicker, the quicker is to go to network settings, go to the network interface, and here you will have two things in help, and you have the effective security rules and effective routes. So here we take some time to charge all the routes, and you will see these routes, and you will see also the different types of routes. So we have the virtual network here, and you have here my usual defined rules that are found here. So this is the effective rules that we can find. And this is how we can spot an error like this if you suspect that something wrong is not working in your network. You can use this. You need to use the VMs. The VMs need to be started, but you can really understood exactly how Azure are routing. Thank you for watching this video. Don't forget to subscribe on the channel so you can be informed when the new video will be added. And thank you again for watching.